if you want to show what h1 is, like h1 is tan h of ux1 plus w of h0. So this in turn is a new expression. H0 is a vector constant, we can say 0 parallel for supposing here, but h1 is in itself an equation or itself a matrix, not a constant. So we will get, actually we will get an output as a matrix or vector. So what happen is we will do inherently implicit differentiation we will do, because in h2 we are inherently calculating all the losses and all the functions which happen in h1. So what happens is here dh2 plus means we will treat like explicit, this is explicit and this is implicit. So like we will treat h1 as constant over here, and then we will get h1 only derivative if with respect to w if you want to do, and this here we will implicit, that means we will treat it as an argument instead of constant. So if you will just substitute this value over here, we will get this and this whole packet. So dl2 by dw is this, and you can also verify that dl2 by dw, so dl2 dy2, then dy2 dh2, then here dh2 by dw, we need to first find dh2 with respect to dw till here, whatever we have found for previously also, like dl1 by dw. So for like that only we need to find dh1 by dw. So dh2 by dw till here we'll get, then it will back propagate to here. So then we have to find dh2 by dh1, this one, to go back, and that into dot product or vector, right? So cross product dot product we will get dh1 by dw here, this one. So this is implicit dh2 by dw, and this is explicit dh2 by dw is explicit, treating y2 as 1. So this dh2 by dw, this one is explicit, treating h1 as constant, and these two dh2 h1 into dh2 by dh1 into dh1 by dw, that is implicit. So this is dh2 plus by dw, this one is explicit, treating h1 as constant, and this whole thing dh2 by dh1 into dh1 by dw is implicit, treating h1 as argument, not as a constant. Similarly, we can say for L3, L4, so on till LT, we'll get a combination generalized version of summation and products. Now next up we will see dl by du for u weights. Here u will be there. So we have just seen for here v will be there, right? So here v, here w will be there. So we have seen for dl by dv, dl by dw. So whatever the impacts the output produces, so with that we'll get loss. So that loss dl by dv means how that is being impacted, how the weights will be changed by using gradient descent dl by dv. We will subtract that, right? So this thing, so we just finding these values dl by dw, dl by dv we have got, these two we have got. So now we will see dl by du. Then we can say that backpropagation happened and training has been done, new weights has been updated, and after an optimized weights and after some iteration epochs or early stop using parameter tuning like hyperparameter tuning, we can stop the iterations or training phase, and that depends on the project to project and workflow. We can set some iterations also instead of using early stopping. Yeah, that depends totally on the workflow and project, etc. So now what we'll do is we will just find dl by du, how we can calculate or solve this. After further solving optimization, we get dl by w something like this, and then afterwards like this. And for dl by du again, it's something similar as what we had did for w, and we like that. Wv, what we had did something like similar to that. So we'll get something like this after optimizing that. And here the changes, as you can see, here it was dw and here it was this thing hk minus 1. So this is changes, other than that mostly similar. So yeah, this is the final optimum. After doing some calculation, optimizing, solving, we will get like this.